So as we saw in the last video, we could create an equilateral triangle from a square simply by manipulating the side of the square as kind of a ruler to create an equilateral triangle. However, can we make a bigger triangle? So say we have our square. And here's our square. And this was like the triangle that we made before. Basically, that's what the triangle looked like. Now, if you haven't watched the past video, I really suggest that you watch it because you probably won't understand anything that we're doing in this video because most of it is based off the last video. Anyways, so as we saw before, the side of the triangle was the side of the square. But can we find a length that is longer than the side of the square? Let's try doing this by, instead of using this side, the side of the square, let's try folding a diagonal line that goes somewhat like this. So in order for this to work, our diagonal fold has to make a right triangle here, of course. And let's assume that these sides are equal. So they're the same length. Now, in order for this side to be more than or equal to the side of the square, then the side of the right triangle should be square root 2 over 2 times the side of the square. And for the sake of making this easier to pronounce, let's just say that the side of the square, the length of the side of the square is x. So, why does this work? So let's just try using the Pythagorean theorem, assuming that the sides of the right triangle are both square root 2 over 2 times x. So if we do that, we have square root 2 over 2 times x squared plus the same term is equal to some value, and in the end we're going to square root that value because it's the Pythagorean theorem. So evaluating this, we get 1/2 x squared plus the same thing, 1/2 x squared is equal to x squared. And when we square root it, we have x. So if we assume that the side of this right triangle is square root 2 over 2 times x, then the length of the diagonal fold that we just created is x. Now, since this isn't actually an exact image, let's try using algebra. So if we pushed this diagonal up and made the length of this diagonal longer, then what would happen? Would we still be able to create an equilateral triangle? So here's a smaller version of the square that we had before. Now, the length of the side of the right triangle is still the same. It's still square root 2 over 2 times x, assuming that the side of the square's length is x. So, all we have to do is just prove that the length here is longer than the altitude of a triangle with side x, an equilateral triangle, of course. So, as long as we first find the altitude, and if the altitude right here is less than this line right here, slash altitude from this point, then we will have proven that we could create a larger equilateral triangle. And I'll explain this later. Some of you may already get why this works, because we're creating an equilateral triangle, and this means that we can still, if the equilateral triangle hasn't reached the corner point yet, then we can make the equilateral triangle bigger. So I'm going to change colors to yellow because this is getting kind of confusing. So say we have, here's the explanation for why this works. Say we have an equilateral triangle here, and if it's not touching the final point here, then we can still push up this diagonal base. So the equilateral triangle finally reaches the diagonal point. And when we push this diagonal line further, then the diagonal becomes longer. And this means also that the side of the equilateral triangle becomes larger. So this is exactly what we're going to try and prove. Now, what if this length right here is actually greater than this length? Then that means our whole idea of using a diagonal base for our triangle won't work. So let's get started on the algebra. So here's our plan. First, we're going to find the length of y1, which you can see in the step instructions, I guess. And the second step that we're going to do is find the altitude of a triangle with equilateral triangle with side length x. And our last step, which I haven't shown yet, is to prove that y1 is greater than y2. Now, of course, obviously, we can just see once we find the values, and we'll just show that they are y1. Let's see if y1 is greater than y2. So, once we finish these three steps, we'll know if we can create a larger equilateral triangle. Okay, so let's start with step 1. Here is another mini model of the graph that we made before, and what we're just going to do is find this length, find the length of the diagonal of the square, and just subtract them, find the difference, and then we'll find this length. Pretty simple. So first, actually, we're going to find the length of the diagonal of a square with length x. And obviously, this is pretty easy because we have a right triangle, we have a square at first. Whoops. We have a square, and we have a diagonal. We want to find the length of the diagonal. We can just use Pythagorean Theorem. Now, most of you already know that the length of the diagonal is x root 2. And so I'm not going to go into further explanation on why this is true, because if you don't know the Pythagorean Theorem, then you really shouldn't be watching this video. Anyways, now it's time to find the length of this part right here. So we know that the side length of the triangle is square root 2 over 2 times x. So basically, when we have this triangle right here, from this triangle, kind of confusing, we basically split it in half with the diagonal part. So now we have a triangle with hypotenuse square root 2 over 2x. Now what do we do with that? Because these are similar triangles, everything here is a similar triangle, I'm not going to go into further detail, but we find that the length of this side right here is equal to 1/2 x. And we could have also found it because we knew that the hypotenuse of the triangle was x, so we just divide it by 2. So you can go either way, using similar triangles, or the simpler way, just knowing that the hypotenuse of the original right triangle is x. So we have 1/2 x, and we have the value x root 2. This gives us root 2 times x minus 1/2 x. And we found the value, square root 2 minus 1/2 times x, using the distributive property. Okay, step 2, finding the altitude of an equilateral triangle with side length x. This also is pretty easy, and we don't really need much thinking. So, we know that the altitude splits the triangle in half, so the length of this should be x over 2. And since it's an equilateral triangle, we also know that this is x, because all the side lengths are equal. So we have two lengths of a right triangle, x and x over 2. What can we do? Pythagorean Theorem. So let's use the Pythagorean theorem. Since we have a hypotenuse and a side of the right triangle, we can use Pythagorean theorem to get x squared minus x squared over 4. And we just have to evaluate this value, which is 3/4 of x squared. Of course, we also have to square root this value. So we have the square root of this, which is equal to square root of 3x over 2. So we've just found our other value. And also, most of you already know that the altitude of a equilateral triangle with height x is, with side length x, is square root of 3x over 2. So if you already knew this part, you should have skipped it. Okay, so we have our two values, and all we have to do is just compare them, see if y1 is greater than y2. Now, of course, we can't actually compute these values because they're square roots, and even if we did square the values, we'd still have this annoying 1/2 here to deal with. So instead, I used a calculator and rounded the values to the nearest 100th. So we have y1 is about 0.91x and y2 is about 0.87x. And since y1 is indeed greater than y2, we can make an equilateral triangle larger than the one that we made before. All of that for just an equilateral triangle. Thanks for watching.